In this video, we're going to talk about percent by mass. Percent by mass is a very simple mathematics, and so I'm going to give you a couple of examples, see if you can pick up on this topic. Let's take something like water real quick. Percent by mass. You'll notice it says mass. That means you're going to get your numbers off the periodic table. So what you're going to do is you need to make sure you have your periodic table out for this section. If you don't have that, go ahead and pause the video, come back when you have it. Now, if you look at the periodic table, you can take the mass of all the elements, the decimal numbers, and you're going to round them to whole numbers. Now, do the rules that your teacher asks. Sometimes they want you to write every number off the chart. I have my students just round to whole numbers. Make sure you do what your teacher asks. If you're watching this video to learn it, you can just do it just like I'm doing it. Oxygen on the periodic table has a mass of 16. Hydrogen has a mass of 1, and there's 2 of them, so that's a 2. Grand total, 18 grams. Percent by mass is this simple. Hydrogen is going to be 2 grams out of the 18 grams, and oxygen is going to be 16 grams out of the 18 grams. Part over whole, part over whole. Now, I grab my handy-dandy calculator, and I'm going to take that divided by that times 100, which is going to give me percent. And so I'm going to take 2 divided by 18 is 11 times 100. There it is on my screen. 11.11111. So I'm going to go 11.1%. The next one is 16 divided by 18 times 100. And that is 88.9%. First thing you need to notice, those 2 percents have to equal 100% because they're the only elements. And you'll notice that those 2 numbers added together equal 100%. Percent by mass is pretty simple. Now, there's another compound, H2O2, which is hydrogen peroxide. Do you think it has the same percentages as water? Let's see. Oxygen is 16 times 2 is 32. Remember, I'm getting these numbers from the chart. Hydrogen is 1 times 2 is 2. 34 is the grand total. So 34 grams on the bottom. So hydrogen is 2 grams out of 34. And this one is 32 grams out of 34 grams. Times 100. So 2 divided by 34 and multiply times 100 is 5.9%. And 32 divided by 34 is times 100 also, 94.1%. Now notice, both compounds are hydrogen and oxygen. Their formulas are so close, but their percentages are not. Here is a very important statement. Whenever you do percent by mass, there's only one compound in the world that has 5.9% hydrogen and 94.1% oxygen, and that is this compound. There's only one thing in the world that is 11.1% hydrogen and 88.9% oxygen, and that's water. Now that becomes very important in CSI work. When you talk about CSI work, you're talking about, and that's a very popular television show right now, crime scene investigation. When they find an unknown substance, what they'll do is they'll take that substance and scrape it up and send it to the lab, and it'll be analyzed, and they'll come back with percentages of the elements, and that percentage of the elements is going to help them know what that actual substance is. So what I'm going to do next is I'm going to take the percent by mass, and we're going to see if we can get the answer back. Now see if you can follow along with this. Watch very carefully. Let's say we had an unknown compound that was 11.1% hydrogen and 88.9% oxygen. So we found this at a crime scene. We sent it to the lab, and this is the result that came back. Now, if you'll notice, what I'm going to try to do is I'm going to try to get H2O back. So we're going to take this percentage and try to get that formula. And so watch very carefully how I do this math. So we send it to the lab, and it comes back. Now we said there's only one thing in the world that has these exact percentages, so let's see if we can figure it out. Now, since percent means parts out of 100, the very first thing we're going to do is we're going to assume that you had 100 grams. Because if you assume that you had 100 grams, this becomes 11.1 grams of hydrogen, and this becomes 88.9 grams of oxygen. So those two numbers add up to 100. Since percent equals parts out of 100, if I pretended that I had 100 grams, 100 and 100 equal each other, now I all of a sudden now have something I can work with. Now, I can't compare anything in grams. I have to turn those grams into moles. And you've done this before. 1 mole, it's always a 1 with mole, has grams. Now what we're going to do is we're going to use the chart again, using the weights off the chart. Hydrogen's a 1, oxygen's a 16. Hydrogen's a 1, oxygen's a 16. Now, all you do is this. 11.1 divided by 1 is 11.1. And moles, because the G goes away. So does this one. 88.9 divided by 16 is, do that again, 88.9 divided by 16 is 5.56 moles. And there's my answer. Now, have you ever seen a formula that is H to the 11.1 and O to the 5.56? Well, I've never seen a formula like that. It's supposed to have whole numbers, like this, H2O or whatever numbers. So how do you get whole numbers? Well, you figure out very quickly, find the smallest number and divide everybody by that smallest number. That becomes a 1. So 5.56 divided by 5.56 is a 1. So if I take 11.1 divided by 5.56, that is 1.996, which is, I can tell that's a 2. So when I compare this to this, I get a ratio of H, 2 of them, to O, 1 of them. And you will notice I just got the formula back. Taking the percent and figuring out what the unknown substance is. This is real CSI type work. This can be part of the chemistry work of crime scene investigation. Taking the percentage that you got of an unknown substance and getting its formula. So I'm going to give you one more. Let's see if we can get this one together. And in the next video, we'll try another. Okay? In this one, we have an unknown substance that has 66.0% calcium and 34.0% phosphorus. All right, let's do the math. I'm going to do it just a little faster. These become grams, 66 grams of calcium and 34 grams of phosphorus. Can't use grams, you got to have moles. Gram to mole, 1 mole. Gram to mole, 1 mole. So I'm going to have to use my chart. Calcium, as I look it up, is a 40. Phosphorus, when I look it up, is a 31. Now again, I'm using whole numbers, but it works fine. 66 divided by 40 is 1.65 mole. And 34 divided by 31 is 1.096. And I try to carry a couple of decimals to make my life a little bit easier. So divide by the smallest, 1.096. 1.096. So I know that one's a 1. 1.65 divided by 1.096 is 1.5. Now this is going to be tricky. You've got to really watch me. I was supposed to have whole numbers. So is the answer CA 1.5, P 1? Well, that can't be the answer either. But I've already divided to get whole numbers. Now, very tricky. This happens every once in a while, so I'm going to go ahead and show you how to do it. Watch carefully. If I have 1.5, 0.5 is a half. In mathematics, if I want a half to go away, I multiply it by 2. Because when I multiply it by 2, a 2 on top and 2 on bottom disappears. If I had something that was a third, what do you think I multiply by? A 3. What happens if I had a quarter? I would multiply by 4. Now you'll notice it came out, since I carried my decimals further, I got a half. If I multiply them both by 2, so I'm going to multiply times 2 to get rid of the half, that becomes a 3, and this becomes a 2. So it becomes CA3, P2. So CA was a 3, and P was a 2. Now let's use some logic that we know. On the periodic table, if we look at the periodic table, and this sometimes helps us, calcium is in the +2 column, so Ca is a +2, and phosphorus is a -1, -2, -3. Ah, look, I actually got the right formula when I crisscross. So I know that one's probably right. I got the right formula. Now, Am I always going to be able to look at the chart and know exactly the formula? No, there are some odd formulas in the world. There are thousands of compounds in the world, but in this case it proves how it works. So one more time, take the grams to moles. When I get moles, divide by the smallest mole so everything becomes whole numbers. If something happens and you get a half, or you get a third, repeating threes, you would multiply by a third. If you get 0.6677, that's 2/3. You would have to multiply by that 3. You're trying to make it be whole numbers. Doesn't happen very often. These are called empirical formulas. It comes from percent by mass. In the next video, you're going to try a couple on your own.